Now this last one is, of course, the famous one. It's very profound. Let me tell you what it means, and then I want to tell you a little bit about where it comes from. What it means is, it's what we talked about a moment ago. If I have two particles, let's say a proton and an antiproton, or an electron and a positron, or an anti-electron, each of those has a mass. If I bring them together, they can vanish and nothing is left but light. And the amount of energy in that light is given by this equation. You take the masses of the particles, multiply by this number, and you get the amount of energy that you can get if you get rid of those masses. It tells you the energy content of mass or the mass content of energy. The flip side, the opposite is also true. Let's say we just had some very bright light. I mean very bright. You can just have things spontaneously appear. Matter can appear by taking some of the energy of that light and turning it into particles. How much matter you can get is by this equation. That much mass for that much energy. And this is just a proportionality constant, c squared. Okay? It turns out it's a very, very big number, c squared. And so a tiny amount of mass gives you a huge amount of energy. Or it takes a huge amount of energy to create a tiny amount of mass, is how this works out. Because c squared just happens to be a stupendously big number.